Hello students, welcome to my YouTube channel Integrated Physics Studies IPS. एथिरे मु ऑलरेडी प्लस टू सेकेंड इयर सिलेबस कंप्लीट कर सारी एवं मु प्लस थ्री CBCS फिजिक्स ऑनर्स जीई आ MSc फिजिक्स ऑनलाइन क्लासेस रो वीडियोस अपलोड करुच्ची जदि भल लगिला ताले वीडियोस को लाइक करदेव और चैनल को सब्सक्राइब करदेव यू कैन शेयर इट विथ योर फ्रेंड्स ऑल्सो इट्स कम्प्लीटली फ्री ऑफ कॉस्ट लेटेस्ट वीडियो नोटिफिकेशन पाई बेल आइकन को एटी ऑल रे सेट करदेव तापर वीडियोज रो क्लैरिटी बढ़ाई गो टू सेटिंग्स क्वालिटी एडवांस उपरे क्लिक करी यू कैन इंक्रीज द रिजोल्यूशन सबू वीडियोज पाई पीडीएफ नोट्स मु पठेबी जोटा एठी ड्रॉप डाउन लिस्ट को क्लिक करी यू कैन गेट द लिंक फ्रॉम द डिस्क्रिप्शन बॉक्स तापरे मोर चैनल नेम को क्लिक कले सबू वीडियोज को मु यूनिट वाइज एच पार सिलेबस सजाई की रखिथिबी व्हिच यू कैन गेट फ्रॉम द प्लेलिस्ट एठी सर्च करि परिबो ओके थैंक यू हेलो स्टूडेंट्स आज रो टॉपिक रे हमें यूनिटरी ग्रुप SU2 एंड SU3 आ ता सहित रोटेशन ग्रुप SO3 एंड देयर रिप्रेजेंटेशंस ए विषय रे पढिबा ऑलरेडी हमें देखिला ग्रुप होची गोटे कलेक्शन ऑफ एलिमेंट्स ताले जदि हमें कलेक्शन ऑफ ऑल नॉन सिंगुलर मैट्रिसेस नहीं जबा हैविंग ऑर्डर सपोज n with matrix multiplication as the law of combination ताले याकू हमें कहिबा फुल linear group बा FLG shortcut रे and the order of this group will be infinite because the elements are the infinite in number of linear transformation that will change the given vector into a new vector, right? So if we impose certain restriction upon the matrices of its transformation, then we can obtain many subgroups of the FLG, that is full linear group. Suppose for example we may exclude all matrices except those jahar determinant plus or minus 1 houthuba. Okay, so if the elements of such groups are infinitely denumberable, then the groups are discrete. On the other hand, if the elements are non-denumberable, then such groups will be continuous. Okay, so दुई प्रकार आम डिवाइड करदेला ग्रुप्स को गोटे है discrete आ गोटे है continuous. Now a subgroup of full linear group, that is FLG, whose elements are square unitary matrices having again the order n, will be called as n-dimensional unitary group. And further, if the determinant of unitary matrices is plus 1 positive nela, then the subgroup will be called as special unitary group. Okay, by USG. Okay, USG एटा को unitary special group भी हमें कहि परिबा. Okay, having order again n and it is denoted by SUN. Okay, bracket रे जो n अछि, it is showing us the order. Okay, now this special unitary groups may be of any order like SU2, SU3, etc. And let us take for example the simplest one, that is SU2. Okay, so we will take a pair of vectors, suppose x1 and x2 in the linear two-dimensional space, that is capital L2. Now under space rotation they are transformed into their linear combination. या को हमें सपोज लिखिला जते बेले हमें रोटेट करछु माने स्पेस रु बॉडी सेट ऑफ एक्सिस को. ओके, जेटा तमे क्लासिकल मैकेनिक्स रे भी पढितबो. ओके, रिजिड बॉडी काइनेमेटिक्स रे. सो x1 डैश equal to ax1 plus bx2. Similarly x2 dash equal to suppose cx1 plus dx2. ताले मैट्रिक्स रे हमें ए हिसाब रे याकू लिखि परिबा, which is suppose equation 1. Now the values of these coefficients, coefficient माने ए जो a b c d, depend upon the particular choice of the rotation under consideration. को हिसाब रे हमें रोटेट करूछु ता ऊपरे ए कोएफिशिएंट रो वैल्यू डिपेंड करे. And if we consider the rotation for which suppose mod x1 square plus mod x2 square is equal to constant, we find that the matrix of transformation must be unitary matrix, that is U, for which u dagger equal to 1. Okay, माने या को जदि हमें लिखिबा ए जो कोएफिशिएंट रो मैट्रिक्स टा हला a b c d तापरे यार डैगर. ओके, दैट इज a स्टार b स्टार c स्टार d स्टार. ओके, रो कॉलम ही जाइछि आ एठी कॉम्प्लेक्स कॉन्जुगेट नहीं जाइछु. Okay, so matrix multiplication kariba, we are getting this much and it will be a unitary matrix having 1 along the diagonal and off diagonal elements are 0. Okay, so here As I said, A star, B star, C star and D star are the complex conjugates of A, B, C, D respectively. And this shows that ଏବେ ଯଦି ଆମେ equate କରିବା ପ୍ରତ୍ୟେକ element को RHS ସହିତ okay LHS और RHS को then we will get obviously this relation, right? देखो ये first row रे ये first element एटा ହେଇगला 1 this one. Similarly एटी last element एटा भी 1 this one and the rest 2 will be equal to 0. ଆଉ ତା ସହିତ condition ରହିବ यार जो determinant A B C D that is AD minus BC equal to 1 plus 1, right? So these equation will lead to C equal to minus B star and D equal to A star. Okay, यार value एमती आसीबो. So the matrix of SU2 group has the form A B एबे C आउ D रो हमें replacement नहीं गला with A B minus B star A star that is याको यदि multiply करछु माने determinant काढी कि multiply कला equal to 1 हबो. Okay, so एटा आसी गला SU2 group रो format. Okay, now the special unitary matrix in two-dimensional space will be a n square minus 1, that is n जगह रे 2 put कर देले हमें 2 square minus 1 that is 3 parameter group. Okay, so from equation 1 and 2 we will have x1 dash equal to जोटा इथिला okay a x1 plus b x2 एबे x2 dash जगह रे एबे c और d रो हमें रिप्लेसमेंट नहीं गला. Okay, ताले मैट्रिक्स रे हमें अकॉर्डिंगली याको एमथी लिखि परिबा which is now equation 4. Okay, now let us see the irreducible representation of SU2. Okay, so above matrices will provide us one way of representation of SU2. We can form other representations also by considering the symmetric products of the vectors that is x1 and x2 and transforming them as above. Okay, suppose I may consider kariba the set of products x1 to the power 2j, x1 to the power 2j minus 1, x2, then x1 to the power 2j minus 2, x2 to the power 2. Okay, माने गोटे रे पावर x1 रो देखो पावर कमी कमी जाउची, x2 रो पावर बढ़ी बढ़ी जाउची. ओके, लास्ट रे देखो एटी पहुंचला x1 किछि भी नहीं माने x1 to the power 1 अछि, x2 to the power 2j minus 1 and the final one x2 to the power 2j. Okay, let it be equation 5. Now we take a value that is fmj. Okay, जार value हमें ए हिसाब रे याको लेखिला x1 to the power j plus 1 x2 to the power j minus m then square root of j plus m factorial into j minus m factorial. Okay, एठी m कोन m हेगला minus j plus 1 up to plus j और j रो value एठी 0 half 1 3 by 2 and so on. Okay, so ए हिसाब रे suppose हमें गोटे set of products नेला. Now as x1 x3, okay, as x1 x3 transform in their linear combinations according to the equation 4 जोटा हमें ऊपर पाइला, therefore 2j plus 1 function contained in equation 5. equation 5 रे हमें जो देखिला ये जो product there will be 2j plus 1 functions which are contained in equation 5 shall also transform into their own linear combinations under the SU2 group. Okay, so this gives us 2j plus 1 dimensional representation of SU2. And to apply the matrices of representation, let us apply the transformation equation 4 to the function that is fmj and we can obtain like ufmj. ये हेगला u रो वैल्यू जोटा मैट्रिक्स थिला that is a b minus b star a star याको मल्टीप्लाई करिबा fmj सहित accordingly we will get this value. And if we use the binomial theorem ताले याको आउ टिके हमें एक्सपांड करि परिबा. ओके, एठी देखो binomial theorem summation आसीगला q equal to minus j ru plus j, then we have another summation upon I ताले एठी minus 1 to the power एठी t हला then square root of देखो एटी यार जो वैल्यू तुमको देखा पाउच क्वांटम मेकानिक्स रे भी तुम देखि जो तुम मैग्नेटिक क्वांटम नंबर ओके एंगुलर मोमेंटम क्वांटम नंबर मैग्नेटिक क्वांटम नंबर स्पिन क्वांटम नंबर पढ़ुव ओके से जहाँ भी हो एटी जे प्लस एम फैक्टोरियल जे माइनस एम फैक्टोरियल जे प्लस क्यू देन जे माइनस क्यू फैक्टोरियल ओके सिमिलरली तले रहा जे माइनस एम माइनस टी फैक्टोरियल जे प्लस क्यू माइनस टी फैक्टोरियल देन टी माइनस क्यू प्लस एम फैक्टोरियल और लास्ट रे टी फैक्टोरियल एतिकी है दुईटा रेशियो मल्टीप्लाई होची ए स्टार बी और बी स्टार डिफरेंट पावर्स रोची राइट ता सहित फाइनाली एफ क्यू जे ताले एठी टी कौन टी हूँ गोटे सिंपल कांस्टेंट तो नुह यार हूँ नंबर गोटे ओके दैट इज 0 1 2 3 एंड सो ऑन ओके मैं नेचुरल नंबर तुम्हें कही पार सो सिंपली या सपोज आम लिखिदेला q इक्वल टू माइनस जे टू जे u m q j f q j where the resulting matrices whose elements are now can be written as u m a j equal to summation I again this value जोटा हमें replacement नहीं गला okay and they are indicated by u j okay simply u j या को लिखी दिला हमें so they are the unitary and irreducible matrices and there are no other irreducible representation of SU2 and it may be noted here that in the expression equation 8 the summation breaks up automatically for negative powers of A star and B star since the denominator would contain negative factorials which have the value that is infinity okay now let us move further the character of SU2 so SU2 group ro character bahar kariyaku hele let us choose a typical matrix of the group and transform it into a diagonalization from okay diagonal form re yaku ame transform kariba so this may be done by suitable choice of a unitary transformation matrix suppose nigala gote capital V so similarity transformation बढ़िया याकू लिखला v इनवर्स u v सपोज याकू आम लिखला u प्राइम बाय u डैश ओके याकू लिखिदेला आम a डैश 0 0 a डैश स्टार with the determinant of u dash equal to 1 and this condition is obviously satisfied if u dash is of the form that is यदि याकू exponential to the power I 5 by 2 0 then 0 exponential to the power minus I 5 by 2 এই হিসাবে যদি আমি নেউଛୁ তাহলে এই কন্ডিশনটা satisfy করিব so the character of the class to which u and u dash belong will be now given by the character calculation को आमे आसीबा माने ट्रेस बाहर करिबा sum of the diagonal elements so e to the power I 5 by 2 plus e to the power minus I 5 by 2 that is এটা যেহেতু i ଅଛି so imaginary part ର sin term गुडा plus minus कटिଯିବ 2 cos 5 by 2 आसीगला okay so this represents the character of SU2 representation and now the matrices uj which are identical with u dash when the value of j is equal to half must be transformed in such a way that their characters will be same for j equal to half and when this is achieved the characters should be applied to SU2 for any value of L okay suppose हमें substitute कला a equal to e to the power I 5 by 2 अब b को निकला simply 0 then the result will be of diagonal form having u maj equal to e to the power I m5 delta mq okay so এটা ଆସିଗଲା ତମର जो क्रोनेकर डेल्टा symbol so the required character of SU2 एबे हिजिबो केते एटा x हबनी एटा काय हबो प्रिंटिंग मिस्टेक अछि so summation m equal to minus j2 plus j e to the power I m5 याकू हम सॉल्व करिबा and we use rho equal to e to the power I5 okay so finally यार वैल्यू देखो sin 2j plus 1 5 by 2 by sin 5 by 2 हबो this will be the character okay so the irreducible representation and characters satisfy certain orthogonality condition and the normalization conditions also as for the finite groups but in the equations of finite groups okay so the summations must be replaced by integrals जो इक्वेशन गुड़ा लिखा है फाइनाइट ग्रुप रे ताकू आमे समेशन को रिप्लेस करबा को पड़िबो इंटीग्रल रे ओके नाउ मूविंग फर्दर लेट अस सी व्हाट आर पॉइंट ग्रुप्स देखो जदि आमे गोटे लार्ज क्लास ऑफ ग्रुप्स नेबा व्हिच आर वेरी इंपोर्टेंट इन फिजिक्स एंड आल्सो केमिस्ट्री ताकू आमे कहिबा सिमेट्री ग्रुप्स बोली and the symmetry of a body is described by giving the set of all those transformations which preserve the distance between all pairs of points of the body and bring the body into the coincidence with itself okay so symmetry transformation कहले आमे सिंपल कथा हैला स्पेस सेट ऑफ एक्सिस रु बॉडी सेट ऑफ एक्सिस बा अनप्राइम्ड कोऑर्डिनेट सिस्टम रु प्राइम्ड कोऑर्डिनेट सिस्टम को केमती आमे ट्रांसफॉर्मेशन करिबा आ एई ट्रांसफॉर्मेशन जनरली रोटेशन रे हुए ओके ऑलरेडी तमे पढिथिबो क्लासिकल मैकेनिक्स रे तीन प्रकार रोटेशन एंगल which are called as the Euler's angle that is phi theta and psi okay so obviously this set forms the symmetry group of the body okay and the distance preserving the transformation can all be built up from three fundamental operation जेमती कहली गोटे हैला rotation through a definite angle about some axis तापरे हैला गोटे mirror reflection in a plane and then parallel displacement that is the translation okay so the last symmetry operation can occur if the body is of infinite extent माने ए जो 3 नंबर टा okay there is infinite crystal lattice jodi heitbo so for a body of finite extension only the first two symmetry group of a finite body must leave at least one point of the body which is fixed mane in other words all axes of rotation and all planes of reflection must intersect at least at one point since successive rotation jodi ame kariba about the non intersecting axis of reflection in non intersecting planes it will result in introduction of translation and continual shift of the body so ebe ame asiba definition ku what is a point group the symmetry group of finite bodies which leaves at least one point of the body fixed will be called as point groups okay एटलिस्ट कम से कम गोटे पॉइंट को फिक्स्ड करी रखिदेव जो सिमेट्री ग्रुप फाइनाइट बॉडीर ताकू आमे कहबा पॉइंट ग्रुप बोली व्हाइल द सिमेट्री ग्रुप्स व्हिच इंक्लूड द ट्रांसलेशन सिमेट्री आर कॉल्ड एज द स्पेस ग्रुप ओके एग्जांपल जदि आमे नबा पॉइंट ग्रुप रो टू डायमेंशनल रोटेशन या को आमे कहि परिबा r+2 आ थ्री डायमेंशनल रोटेशन दैट इज r+3 तेबे तमरो जो सिलेबस रे अछि SO3 रोटेशन ग्रुप दिस इज नथिंग बट दिस r+3 ओके ए बही रे याकू r+3 लिखा है यू कैन आल्सो राइट हियर SO3 राइट सो द सिमेट्री ग्रुप ऑफ ए स्क्वायर एटा भी जदि हमें नोचो दैट इज C4V okay this is also one type of example so crystal symmetry point groups are called as the crystallographic point groups and are altogether number hela यार 32 okay so आगो देखिबा एबे टू डायमेंशनल रोटेशन ग्रुप दैट इज r+2 okay याको कहि पारो तमे SO2 बोली की so consider the set of rotation of a circle about an axis perpendicular to the plane of circle and passing through its center okay center टा एछि हमें fixed point निगला about the rotation axis then each element of this set can be characterized by one parameter which can be chosen to be the angle of rotations हिगला याको suppose कहला हमें phi with limitation phi is lying between 0 and 2 pi then such a group will be called as the two dimensional rotation group denoted by r+2 okay so let r phi be an element in this group जो कि phi रो limitation again 0 ru 2 pi भितरे then if small r is a vector with components x and y okay obviously এটা two dimensional issue so दुईटा component रहिबो then r phi को हमें लिखि परिबा can be represented by the matrix t phi like r dash equal to t phi r with phi within the limits 0 and 2 pi right सो एठी T5 कोन दिस इज एक्चुअली अ मैट्रिक्स ओके ए हिसाब रे हमें मैट्रिक्स को लिखि देला cos phi sin phi minus sin phi cos phi एटा ऑलरेडी पढिछो तमे क्लासिकल मेकानिक्स रे ओके नाउ इफ r phi dash एटा हे गेला आ गुटे एलिमेंट ऑफ द ग्रुप now represented by t phi dash then the law of composition याको हमें लिखि परिबा t phi dash compose करिबा okay that is t phi plus phi dash so it is nothing but equal to t phi dash t phi and obviously we see that the group r plus 2 that is the rotation group in two dimension is abelian okay एटा abelian देखो चेंज हो जाउची मैट्रिक्स रो जो commute करूची okay therefore all its irreducible representation must also be one dimensional okay and therefore equation 2 जो हमें matrix रो देखुतिला which is an orthogonal matrix of order 2 is irreducible and hence a unitary matrix of eigenvector of t which is being required okay so normalized eigenvector यदि t रो बाहर करिबा it will be found out to be u1 equal to 1 by root 2 1 I and u2 equal to 1 by root 2 1 minus I ये भलिया प्रॉब्लम गुटे तमे सॉल्व करिथिलो प्रीवियस चैप्टर रे ओके जेते बेले तमे सिमिलरिटी ट्रांसफॉर्मेशन रो गुटे प्रॉब्लम फेस करथिलो जो ग्रुप थ्योरी ओके सेतिरे u1 और u2 रो डायरेक्ट वैल्यू निया हितिला ओके so here the eigen values are e to the power plus or minus IL5 okay and these then represent the characters of an irreducible representation but however since there are infinite number of classes so there must be infinite number of representation of each class so corresponding characters को हमें लेखी परिबा नहीं परिबा chi m equal to again e to the power I m phi with m equal to 0 plus or minus 1 plus or minus 2 because each will satisfy the multiple requirement of the group okay so orthogonality theorem character ପାଇଁ ଆମେ लिखि परिबा यार फॉर्मेट हे गेला 0 to 2 pi एटा तमरो लिमिट पडिला phi रो then chi m star okay which is a function of phi then chi m dash which is a function of phi d phi and it is found out to be 2 pi delta mm okay ये गला two dimensional rotation group एबे देखिबा the three dimensional rotation group that is r plus 3 and as I said it can also be written as SO3 ओके এই বইরে ইয়াকু r plus 3 बोली लिखिछि सो देखो जदि आमे चूज करिबा गोटे n subgroup of FLG that is full linear group such that it contains all unitary matrices of order that is n cross n with real elements having determinant again equal to plus 1 then the subgroup will be called as the n dimensional proper real orthogonal group or the rotation group आज यदि एठी n रो वैल्यू हे गेला equal to 3 then the rotation group will contain real unitary matrices of order 3 and it is called as the three dimensional rotation group that is r plus 3 or SO3 so एथि पई गुटे कंसीडर करिबा obviously गुटे three dimensional object let us consider a sphere having unit radius and the center of which coincides with the origin of suppose the Cartesian coordinate system xyz now जदि एबे xyz आमे गोटे पॉइंट नेला which are the coordinates okay एटा गोटे पॉइंट random point p रो on the surface of the sphere and the sphere is now rotated in any manner such that the center remain fixed okay याको जो हिसाब रे हमें रोटेट करिबा किंतु सेंटर जो पॉइंट अछि सेटा फिक्स्ड रहिबो then suppose एबे नुआ कोऑर्डिनेट हमें पाइला पॉइंट p रो x dash y dash z dash ओके सो ये जो नुआ और पुराना कोऑर्डिनेट भितरे रिलेशन हमें बाहर करिबा ओके याको हमें बाहर करि परिबा by using some matrix that is r alpha beta gamma okay eta Euler's angle ro concept asila which is an element of the three dimensional rotation group that is r plus 3 okay and such a rotation can be expressed in terms of as I said the Euler's angle that is alpha beta gamma okay so it consists of three successive rotation okay gote rotation hoji through angle alpha about the z axis tapare hela rotation through beta about the new y axis and the final rotation is through gamma about the transformed z axis सो या को आमे separately लिखि परिबा alpha beta gamma which is the rotation matrix that is equal to r gamma 0 0 r 0 beta 0 into r alpha 0 0. Okay, so in order to find the representations of r plus 3, we first show that r plus 3 होउची गोटे homomorphous group with SU2. Okay, and since we know the representation of the later माने ए जो SU2 may be used in same results for r plus 3. Okay, so याको बाहर करिवा पे हमें फर्स्ट नोट करिवा any two dimensional matrix can be represented as a linear combination of four matrices. Okay, जे कौन सी टू डायमेंशनल मैट्रिक्स को एटा प्रॉब्लम रे भी सॉल्व करथिलो p1 p2 p3 p4 माने 0 1 1 0 0 minus I 0 1 0 0 minus 1 and 1 0 0 1. ओके ए चारटा मैट्रिक्स रो कॉम्बिनेशन रे हमें जे कौन सी टू डायमेंशनल मैट्रिक्स को लिखि परिबा बा रिप्रेजेंट करि परिबा. सो एटी प्रथम तीनटा मैट्रिक्स p1 p2 p3 याकू आमे बहुत भलो भाबरे जानिछु दीज आर द पॉलीस्पिन मैट्रिसेस. ओके, सो फॉर एग्जांपल जदि हमें h इक्वल टू गोटे मैट्रिक्स नै गला दिस मच तले h को हमें लिखि परिबा lambda 1 p1 plus lambda 2 p2 plus lambda 3 p3 plus lambda 4 p4 where the values of lambda 1 2 3 4 are accordingly this much. Okay, now let us choose lambda 1 2 3 4 as xyz और 4 हेगला जेमती एटा 0. Then we have h equal to this much. Okay, which can be written in terms of matrix like this. Okay, z x plus iy x minus iy and minus z. So in particular if x y z are real numbers then h will be Hermitian matrix and moreover its trace will be 0 means sum of the diagonal elements will be equal to 0. And in fact any two-dimensional matrix having the trace 0 may be put in this format without the need of the fourth matrix that is P4. Okay, so if we now transform H by an arbitrary unitary transformation by using the matrix that is U जोटा हमें पाइथिला a b minus b star a star with the determinant u equal to बाहर कर देला हमें equal to 1. Okay, so trans will remain unchanged, so it is h dash, okay, which is a function of the new coordinates that is x dash y dash z dash. याको हमें similarity transformation रे ये बढ़िया लिखि परिबा u डगर h u याको सॉल्व करले देखो एतकी आसी गला. Okay, now since the determinant of a matrix remains unchanged after unitary transformation, so निहाती भाव रे h mod equal to h dash mod और simply हमें याको लिखि परिबा जो magnitude कोई परिबा सही पॉइंट रो रेडियस वेक्टर बा पोजीशन वेक्टर. ओके, यार मैग्नीट्यूड टा हमें समान नहीं गला in both the frames. Okay, so this means that the length of a vector remain unchanged by the transformation or by the rotation. Okay, which is shown by equation 5. Hence the transformation must be rotation. Okay, एटा हमें प्रूव कला जे जेहेतु लेंथ टा चेंज हो नाही तेणु एई जो ट्रांसफॉर्मेशन टा निहाती भाबरे गोटे रोटेशन ही हेइथिबो. ओके, माने पॉइंट रो डिस्टेंस से जो सेंटर रु समान रहउची. ओके, मे बी तारो डायरेक्शन चेंज ही पारे किंतु मैग्नीट्यूड ऑफ द लेंथ रिमेन्स कांस्टेंट. ओके, नाउ लेट अस चूज the special forms of matrix U. Firstly, I may put kariba a equal to e to the power I x by 2, then b equal to 0. Tale diagonal matrix hame paigala, so that is u1 equal to this much, and we then find u1 p1 u1 u1 dagger p2 u1 u1 dagger p3 u1 accordingly तीनटा हमें value पाइला. Okay, with these results equation 3 will become this much. Okay, এটা equation 3 आसीगला and this obviously represents a rotation through an angle that is এটা হবো alpha. Okay, এটা small a হবনি alpha হবো about z axis and can be represented as suppose r dash that is rz alpha r. Okay, rz alpha ର value ହେଇगला एतिकी और याकू आमे 3 cross 3 matrix रे ई बढ़िया लिखि पारिबा. Okay, एठी r dash आउ r रो accordingly याकू vector रे in terms of components हमें एमती लिखि पारिबा. Okay, thus The elements are e to the power I alpha by 2 0 of SU2 corresponds to the rotation through an angle alpha about z axis of the group R plus 3, that is SO3. Okay, again I am saying R plus 3 is SO3. Similarly, changing, suppose now value have change कर देला a equal to cos beta by 2, b equal to I sin beta by 2. Again सही हिसाब रे हमें यदि आगु proceed करिबा, we will get the next second matrix which is this one. Okay, एठी बीटा ହେଇଗला the second Euler's angles. Okay, तापरे यदि हमें यूज करिबा equation 8 और 9 को in equation 1, we find that the unitary transformation, that is u alpha beta gamma ହେଇଗला एठी r नो एटा gamma हबो. Okay, so accordingly याको हमें put कला values गुडा and we are getting equation 10. So we now notice that two rotations, that is r00 and r02 pi 0 denote the identity of the complete rotation group, that is r plus 3, and the unitary matrices associated with them are e equal to 1001 and minus e equal to minus 100 minus 1. Okay, by এটা identity element କହିପାର ତମେ. Okay, so obviously the operation r00 then r02 pi 0, which represent the same element of r plus 3, will correspond to two distinct unitary matrices of the SU2 group. So ये भितरु गोटिए ହେଲା negative r गोटे रो. Okay, thus the complete rotation group, that is r plus 3, is 1 to 2 homomorphous to the group SU2. এটা हमें prove कला. Okay, now from the irreducible representation of SU2 we can obtain those of r plus 3 by picking out those matrices which correspond to the matrices or the elements of r plus 3, since there is 1 to 2 homomorphism. Okay, माने 1 to many ହେଇଥାଏ homomorphism रे, एठी गोटे सहित दुईटा रो homomorphism देखौची. Okay, between r plus 3 and SU2, and it is obvious that equation 10 जो हमें देखिला, we have a equal to e to the power I alpha plus gamma by 2 cos beta by 2 और b रो value है I e to the power minus alpha minus I alpha minus gamma by 2 sin beta by 2. Okay, so equation 8 रे यदि हमें देखिबा equation 8 रे last section जोटा हमें देखिथिला, accordingly हे गला हमरो equation 8 with j equal to 0 half 1 3 by 2, and for j equal to 0 यदि स्पेशली हमें पुट करिबा ताले u0 alpha beta gamma equal to 1 हैला, j equal to half हे गले we get the equation 10 जोटा ऊपर हमें पाइथिला. So equation 12 actually represent करूची irreducible representation of r plus 3. Okay, एबे यदि देखिबा finally the character of representation, it can be found from equation, that is chi j, which is equal to summation m equal to minus j to plus j e to the power I m phi. Okay, याको हमें बाहर करि परिबा जेमती unitary group रे बाहर कला, and since e to the power plus or minus ix equal to cos x plus or minus I sin x, so they can be expressed as chi jx equal to 1 plus 2 cos alpha plus so on up to 2 cos j alpha. Okay, एठी j रो वैल्यू 0 1 2 3 जदि हमें एठी याको कंप्लीट नंबर नोचू. ओके, आ जदि काय जे अल्फा आ गोटे सेट जदि हमें नोचू 2 cos alpha by 2 plus 2 cos 3 alpha by 2 and so on up to 2 cos j alpha, we are taking the value of j to be a fraction, that is half 3 by 2 and so on. Okay, ए हिसाब रे हमें कैरेक्टर यार पाई परिबा. Okay, so up to this I have taken the unitary group SU2, SU3 and the rotation group SO3 जोटा ए बही रे R plus 3 लिखा ହେଇଥିଲା और तार representation this I have taken from one book. Now you see this I have taken from another book. Okay, ए बही रे याको आहुरी detail way रे explain करिछि. Okay, with some useful diagrams. Okay, broad way रे याको explain करिछि. You can read from this book also. Okay, for your knowledge purpose. And एठी देखो स्पेशल यूनिटरी ग्रुप्स SU2 SU3 पूरा यार डिटेल सेम जिनस जेमती आमे ऊपर बही रे देखुथिला किंतु आउ टिके डिटेल देइछि. Then the homomorphism between SU2 and SO3, এই বইরে দেখো ইয়াକୁ SO3 দেଲା উপର বইରେ R+3 ଲେଖିଥିଲା okay. Then finally we have the irreducible representation of SU2 okay. So I advise you to read from this book also and make your note accordingly okay.
Thank you.